Okay, so in this lesson I'm going to talk a little bit about the software design aspect. So far we have seen that the car object has only three data members, three instance variables, which are year, make and model. Now what if we want another object to be related with a car object? So we are creating two objects and those two objects have some kind of association. So in UML, which is Unified Modeling Language, or object-oriented programming concepts in general, there are two types of associations between classes which are interesting. There are many more types of associations, like we will see later, like inheritance and so on. But two types of association that are interesting are, I'll write this here so that you can see, composition and aggregation. So composition association means when one object is a container object that contains a second object which is called contained object, but in such a way that if the container object is deleted or doesn't exist, is destroyed, then the contained object also is destroyed. So they don't have a separate, or the contained object doesn't have a separate existence. Aggregation relationship, on other hand, is when a contained object can exist by itself, but it also, a container object can hold a pointer, for example, to the contained object, so that the contained object can exist by itself, and if the container object is destroyed, the contained object can still remain. So we will talk more about this and how this is depicted in UML later on. But to demonstrate this, what I'm going to do is, the first thing is I'm going to add a new class, and this new class is just going to be a person class, which is a very simple representing a person. And we will make the person class here. So person class has a default constructor, and in the person class I'll just use hash include IOStream here, and using namespace std because we also want to output certain things. And in person.cpp, in the default constructor excuse me, we will also hash define debug, because that's a good practice whenever we want the debug code. Later on we will see how we can put all of this in one file. We don't have to remove this debug, find wherever all these macros are defined. We can just put them in one file. So for now, and I'm going to do conditional compilation, hash if def debug hash and if, and in this case we have a cout, default constructor of so we are calling the default constructor of person class, so that we know that this was called. And another thing I forgot to add is we will add a private member to this class, and that could be just a string name, so name of the person. And in the constructor we will initialize name. I need to follow the style guide, so I have to have an underscore, trailing underscore. So this is just a very simple basic class. Name is equal to John. Okay. So this is the person class constructor, default constructor, initializes name to John, and prints out. I will also add another constructor because I want to show you certain things. It's always nice to have a constructor that will take a string name and then I'll add the definition, refactor, add definition. For this I will just use the initialization list. so that you get used to it. So this initialization list here is initializing the instance variable name to the argument name that is being passed. And just so that we can see that this particular constructor is called, we will have an output. So one argument constructor of person class called. Okay, so now our person class is ready. It's a very basic class, nothing much in here. And now what I'm going to do is, in car class I'm going to add a person object which is the owner of the object, owner of the car. Now this car class doesn't know anything about the person class, so we need to include. And if you remember, I talked about hash include, we put double quotes and person, so that we know, or compiler knows, that this person class is our header file that we have, or person file that we are including is a header file that we have created. And angle brackets or less than greater than symbol, that indicates to the compiler that this string class is a standard library, which you can see here is in the standard place. And if I place the cursor here, I think it will show me that the person.h is in my own folder. Okay, so now car class has a person owner, and now we need to fix the car class constructors so that we have that included. So let's assume that the default constructor, and I'm just going to focus on the default constructor for now so that you can see that what's going on. So in the default constructor, first of all, what I'm going to do is this: I'm going to create a owner. We know that owner is a person object, and owner is a person that has name Bob. Okay. So what we are doing is, we are initializing all these members here, year, make and model, and then owner is the person Bob. So we are creating the owner object, which is, this is creating a new object, and that object is then assigned to owner, which is the data member in the car class, and the person object will be created. Now for also we can, so that we can see this reflected here, we will say in the print function we will add a line saying owner is, and owner dot name, and of course we need a get method for that, so I'll add get method also for now. Okay, so NL so we will also print the owner's name. And because we don't have access, now if I compile this code, let me show you, the everything else works, and it says class person has no member called name, because we don't have a name method. If I write directly that there is a name variable data member that belongs to a person object, then we will get a different error saying that we don't have access because it's private. So although a car object contains a person object, name is a private variable inside person, so we cannot access it directly. There are a couple of ways we can get around this. One is we can make it public, but that's violating the object-oriented principle, so we will not do that. Another way is make car class a friend class of class person, but we'll talk about that later because it has some little intricacies there. So the easiest way, which is the right way to do, is create an accessor function which is going to return a string, and we call it name, and this is accessor for name, and I'm going to add the definition in person.cpp, and it return name. Okay, so now if I compile the code, we get oh, I need to change this here in car.cpp, change it back to calling the accessor function now instead of calling the variable. And now my code compiles. We have function, this print will print the name. Okay, so now I'm going to not change anything here, and instead of calling the one argument constructor, I'm going to call the default constructor. Well, I'll just keep it simple. We'll create a car C and c.print. Okay, so we are creating a car object C which uses the default constructor, and then we print the information about the car object. That's all. So let me run this code and you will notice some interesting things here. Okay, so as I run now this code, you can see here now two things are happening. One, we see default constructor of person class called, and then one argument constructor of person class called, and then that shows that we have called the default car class constructor called. Car is Toyota Camry, year 2005, 15, and owner is Bob. So let's see what's going on, because let's trace. So in main we have created a car object C, so which looks fine. So let's go, which calls the default car class constructor. Let's go and see what's going on in here. So we see that in this line we are initializing the year, make, and model, and then here this is actually calling person class constructor, which takes one argument. So we see this line creating the person class constructor. So we see that in output also, that we have the one argument constructor of person class called, and then we see the output default car class constructor called. So that all explains, it can be explained, but what's going on with the first line which says default constructor of person class called? We never called the default constructor of person class. So what's going on in here? So what happens is this: because the car object contains, and let's see in the header file here, car object contains 4 data members: year, make, model, and owner. So all of these are initialized when the constructor is called, and since in the initialization list here we don't have anything which is initializing the person object, the owner, the compiler automatically creates, using the default constructor, it creates a person object, and that person object is then assigned to owner, because we know that car class has 4 members. So that's why this is the line 17 is where the default person class constructor is being called, and then when we call it here we are explicitly calling one argument person class constructor. So that's not very efficient because we don't want that to happen, and we are creating 2 person objects although we need only 1. So that's when we actually use this is efficient to use. Now you will see this new syntax here. It's not new actually, where we create the owner object of person class and pass Bob as a string to this constructor. So this is actually calling the one argument constructor of owner, and the value Bob is passed, so that now there will be only the person class constructor will be called only once. So now if I run the code, you will see now here we have one argument constructor of person called, default car class constructor, and car is Toyota Camry, owner is Bob. So now we don't have 2 objects of person class created, we only have 1 object being created. So that's when the initialization list is actually also helping us writing efficient code where we are not creating unnecessary objects. So I'll stop this lesson here, but I hope you got the idea, the importance of initialization list. Although we could do the same thing here, but then constructor also creates 2 objects, one in this line 17 using the default which we don't need, and then one here. So there is no memory leak as such, because that object which was created initially will be destroyed as soon as we exit the constructor, but still this is not very efficient, especially if you are doing a lot of processing in the constructor. Okay, thank you.